So where I'm going to start with is just to make sure I get everything in the right units, okay? SI units. So R equals 100 meters, no problems there. 36 kilometers per hour. You're always going to get things in kilometers per hour, so get used to the conversion, right? So what's this? 36,000 meters? And by now we're used to the fact that how many seconds are there in an hour? 3,600. Okay. So that's kind of convenient. That's nice. All right. The mass is 80 kilograms. So now I'm trying to resolve all the forces. And like I said, you've got a horizontal one and a vertical one. In fact, you can go straight back to here, right? So vertically, what's going on? Vertically, the normal, right? It's just going to be equal to the mass times gravity. That's it. And you're talking in newtons, right? I suppose if you were doing kilograms, it'd be different, but that's that. It was simple. That's all you needed to do, okay? Likewise, when you're working out the friction force, right? You're going to go here, mv squared on r, and you know what all of these pieces are, right? You got your 80, that's m. V squared is going to be 100, and r is also 100. Looks slightly suspicious that it's the same number, but it's not really because I haven't multiplied by gravity in this case. Okay. So now we're going to go and work out the angle, but because we did our work here, all you need to do is take back this and then see if you get a reasonable result at the end, right? So when you're saying, this is part B now, theta equals tan inverse of 100 on 100g, right? So this is just 1 over 9.8 or whatever you like, okay? Now, I think, let's do it nearest minute. What did you get? And was it an intelligible answer? Did it make sense? Someone? Anyone? Jarid? I think I saw you had maths, right? What'd you get?
5 degrees and 50 minutes.
Okay, now, does this make sense as an answer? Is it within a reasonable domain? Yeah, I think it is. Just like with our, I rubbed it off. Just like with our banked tracks, right? You're not having huge angles here to get the desired effect. He's going quite fast for a cyclist, right? And he only needs to lean this far. Which, by the way, tells you a little bit about the cyclist that I showed you, how far he was leaning, and therefore how fast he was going, right? Likewise, if you think about, where is it? R here, right? So R appears here in the denominator. So what happens as I decrease R? As I decrease R, right, this whole thing is increasing in size, which means the angle is also increasing in size. That makes sense. Decreased R, it's a tighter turn. So you've got to lean in harder. Does that make sense? This angle's away from the vertical. So you're going further over, right? So there you go.